I'll make up my own, but let's give you a little rundown of what the final is going to be on, and we can add to that anything. You can ask questions after this on homework or on going over a topic or whatever. The 4 main chapters for the final are chapter 11, sequences and series. Then we did 3D stuff, essentially lines and planes. And then we done the calculus of multivariate functions. And then we finished with partial differentiation. Excuse me. Actually, the multivariate really belongs there. Now, if I move over to one of the pages that I have got, and hopefully I open the right window. Here is a kind of more detailed list of those chapters. Now, for the most part, your final exam, which has 10 multiple choice and has 10 section 2 questions, will be chronological. So the first thing you're going to see is from the beginning of chapter 11, and the last things you will see are, excuse me, partial differentiation or general. So that is pretty much it. So now we end, good grief, excuse me. Hold on a second. Okay, I should be good now. I have asthma, and that's normally for me, when I get this coughing that I can't get rid of, it's normally a sign that my asthma's making its appearance. Okay, who's got a question for me? Start the ball rolling, somebody.
Okay, so I've got one, and it's in the
Couldn't hear you, Sam.
Sorry, the space is messing up where I'm scrolling. Okay, so the problem, oh, where is it? I just lost it. Oh, there it is. Okay, so it's find the Taylor series for f of x centered at the given value a.
What was the given value b?
A is -2.
Okay, and what was the function?
F of x equals 4 over x.
And is this one the entire Taylor series or just a T3 or a T4? What's it asking for?
The entire Taylor series.
Okay, so.
And then find the radius of convergence afterward.
Gotcha. Maybe the interval if they wanted to as well. So what we're looking at here, let's move some windows around so I've got some space, is that we need to set up a set of derivatives. And the reason we're going to do that is we're going to be on the hunt for patterns so that I can find the nth derivative at x. And why do I want that? Because then I can find the nth derivative at -2, because Taylor's series centered at a is n equals 0 to infinity. The nth derivative at a, x minus a to the n over n factorial. Well, that guy and that guy are fixed, right? They're just there all the time. So I just need to know a formula for the nth derivative, in this case at -2. And once I know it, I'll put it in there. So that's my goal. So I'm not going to worry about the -2 right now. What I'm going to worry about more is seeing if I can find a pattern in the derivative. So, okay, that's f of x. It is what it is. If I want to find its derivative, it's probably a good idea to call it that. And then if you multiply it, you get -4 x to minus 2. If I want to find the second derivative, it's negative 4 times negative 2 x to negative 3. I'm just going to keep this going until I think I see a pattern. It's going to be negative 4 times negative 2 times negative 3 x to negative 4. I think I've got the pattern. It's going to be negative 4 times negative 4 to 2. Right? If I continue this to some arbitrary point n, right, the nth derivative, what we're looking at here are things that stay the same and things that change. So I'm going to look at the power of x. Would you agree it's negative? The first derivative, you get 2. The third derivative, you get 4. The fourth derivative, you get 5. So the nth derivative would get you that. Are you happy about how I got that part? Now, this 4 is fixed, so there's always a 4. And now I'm going to try and just rearrange this a tiny bit. I'm putting the 4 here, and I'm sticking the 1 next door to it. Now, when I write it that way, I got a 4, yep. All these negatives, I want to take care of them. So this guy is negative 1 squared, 1 times 2. And this guy here is negative 1 cubed, then 1 times 2 times 3. And this one here is negative 1 to the power of 4, 1, 2, 3, and 4. Okay, we're almost there. Negative 1, well, second derivative, negative 1 squared. Third derivative, negative 1 cubed. Fourth derivative, negative 1 to the 4. Can I say nth derivative, negative 1 to the n? Do you see how I took care of the negatives now? Now, what about what's left? The second derivative, you have a 1 times 2. The third derivative, you have a 1 times 2 times 3. The fourth derivative, you have a 1 times 2 times 3 times 4. What will you get for the nth derivative?
In factorial.
Yeah, n factorial. Now, what I've got here then is essentially the general formula for the nth derivative, right? So that's good. Now I'm going to find the nth derivative at a, which is at negative 2. So it's going to be 4, negative 1 to the n factorial. I think this would probably be better written like that. Would you agree that negative powers are kind of awkward? And so what I really would get is this fella, 1 over negative 2 to the n plus 1. And bingo. The nth derivative at a. So I'm going to swap places here. So our Taylor series is going to be n equals 0 to infinity. The nth derivative at negative 2 which is that guy, times x take away negative 2 is x plus 2 over n factorial. So that is Taylor's series, but now I'm going to do style points. That n factorial gets cancelled. And I'm going to take this slowly. And I'm just going to write down what we have left right now. Negative 2 to the n plus 1 can be rewritten as negative 1 to the n plus 1 times 2 to the n plus 1. Are you happy with that being this guy? I'm just trying to make this as tiny and as simple as I can get away with. There is a cancelling going to happen here, but it's not a complete cancel, right? They don't totally destroy each other. Would you agree that negative 1 to the n cancels out negative 1 to the n plus 1, but aren't you left with a negative 1 left over? And that's where this negative came from. Now, I'd be really happy with that answer, and maybe WebAssign is, but I can do better. Four is really 2 squared, which means that I now have this fella partially cancel, and you have a negative. You have an x plus 2 to the n. And if you take 2 away from this guy, you get n minus 1. That was a pretty yucky question. A lot in that. Are we good? Now, I don't know if WebAssign took it to that stage. You may have left it like that, right? They may have left it like that, I mean. Right? They may have done that. I'm pretty sure they would have cancelled those guys out. Any problems?
Was the thing we just solved the radius convergence, or was that the full Taylor series?
Yeah, so if you want to do the radius of convergence thing, you would find the limit as n tends to infinity of an plus 1 over an. In this case, it's going to be the limit as n tends to infinity of the top guy with n plus 1 on it. Now, if you put an n plus 1 in there, n plus 1 take away 1 gets you that guy. And then if you turn the other one upside down, you get this. So to find the radius convergence, we basically do the ratio test, and we'll get the radius convergence out of that. The negatives essentially cancel each other out, but the absolute value would have done that anyway. This partially cancels, and you're left with an x plus 2. And this cancels and leaves you with 2. So it looks like when you've finished all the cancelling, you've got this guy left. Now, according to the ratio test, this has to be less than 1 for convergence. And, well, that's basically it, except you always need an x here. So multiply both sides by 2 gives me a radius of convergence of 2. If I wanted to find the interval of convergence, I would do that. And that would give me that. And then when I have to test the 2 endpoints to see if they converge or not. So I would test what would happen if you made x equals 0 and what would happen if you made x equals -4. And in both cases, it would diverge. So the interval of convergence would have been that, and the radius is that. Right, this question would have to be a section 2 question. Right? There's no way that would be a multiple choice. A simpler version of that same question would be just to find T3 of x. Right, now T3 means you finish on the third derivative, in which case you don't need to look for a pattern, don't you? Just need to find first, second, and third derivative at -2 and plug them all in. And that would probably have been a little bit easier to do, as it requires less work.
How would you determine whether or not it diverges or converges?
It happens here. When you do this, right, it's called the ratio test. Whatever this limit is equal to, it has to be less than 1 for convergence. If it's bigger than, or, well, actually, if it's just bigger than, then it diverges. And you don't want it to equal 1 because that's inconclusive. So you don't really know if it's going to converge or diverge. So whenever you're doing a Taylor series question, you're always going to be testing for convergence. So it's always less than 1.
Wait, so
Okay.
why does it diverge? This problem specifically?
It would diverge if the limit to this was bigger than 1, but it's not. I wish I hadn't said diverge here. In Taylor series, you're only interested when things converge. Good. Now, if you know when things converge, isn't the rest where it diverges? So you don't go hunting for divergence, you go hunting for when does it converge, and that's what you typically are asked to find.
So where would we put the endpoints again to test that?
Oh, you would go back to this original format. Where was my nicest version? See this guy up here? If you plug 0 in here, right, that's testing this endpoint, you would get -2 to the n over 2 to the n minus 1. That basically means you're going to add an infinite number of negative halves, which is
Negative infinity.
negative infinity. Yes, I'm pausing there for a minute. Yeah, if you add up an infinite number of any number, doesn't it diverge? I'm assuming if you plug in -4, you get a similar answer. It's just positive. What would you get? You'd get positive a half, right? And you'd still be adding up a positive number of a halves because you could pull out another negative, and I'm not sure it would be positive. It would alternate. It would be alternating halves, right? Which would be just as bad because a half, take away a half, add a half, take away a half diverges because it bounces between two numbers, right? It doesn't level off. So these two endpoints are just what you plug in X here, and then later on what's here. Normally, when you do the testing of the endpoints, the series that you get should be very simple. It should be something that you, most of the time, you can just tell by looking that it's a diverger or a converger. I mean, if I see sigma 1 over n squared, don't I know the answer converges? But if I see sigma 1 over n, I know it diverges. If I see sigma half, I know it diverges. And situations like that. Okay, our next question. Or topic. It could just be, could we go over the concept of an insert name there?
Could we go over number 10 and 14.3?
Okay, do you have it handy or will I have to go looking for it?
Yeah, I have it.
Okay, and what does it say?
It says, so it gives us a definition of partial derivatives as limits.
So I remember that question. Okay.
Do you still want me to say it? Because it's...
if it's big, no. I'm going to look it up. It sounds like it'll be big. Is it?
Yeah, so it gives the limits of the partial derivatives for x and y. One of them for x is f of x plus h comma y minus...
Oh, it's just the definition. Okay,
Yeah.
I remember the question now. I'm good.
Okay.
I'm going to find it now. So 14.3, if you can bear with me for a few seconds as I... Oh, come on, stop being slow. There we go. in question 10. I think we all need to, right, I got the, I think it's the phrasing that may have bothered you rather than anything else. You can certainly do it from first principles. I would suggest strongly you don't. So let me show you what this question, when I picked it, what I was expecting from you. And it's not that bad. If you wanted to do this function and you wanted to find its partial derivative, which is all I wanted. Now, they go and they give you, you remember the limit as x tends to a, f dashed of x proof. Remember that guy and the fa plus h take away f of h definitions. Remember doing them a way back in Calc 1. In other words, getting the answer from the beginning, right? I wasn't expecting you to do that. So I was just expecting you to take this guy and find his partial derivative with respect to x. So that's all I was expecting. So you didn't need to do it the way they said. Right. If you're interested, you can certainly look up the partial derivatives. But when you did Calc 1, once we showed you how to find f dashed of x, did any of you ever go back and try and do the answer the long way with the limits? And the answer is no, right? This was kind of a homage to that. I was saying, like, you could do these from scratch if you really wanted to, but nobody would. So just get the answer and call it good. And that's all they're wanting in the box anyway. Well, that was a nice short answer. This question, I could do as a multiple choice. Right, now, imagine that was A, which is the right answer. What would I do in B? Let me give you a sort of a mental idea of how I create multiple choice. Right, so I have a question I think is pretty quick, right? Something you can do really quick, because multiple choice questions, if they take you more than 5 minutes, you're doing them wrong, right? Because a multiple choice question shouldn't take more than 5 minutes, right? So if you think, oh, I'm going to have to do this and then that and then something else, and it's going to take me, 20 minutes, that's not the way to do it. If you think that, pick C and move on. That's probably your best advice. So to give you a kind of insight, I might do this as one of the wrong answers. I might do this as one of the wrong answers. And I might do this as one of the wrong answers. And some other stuff. Each wrong answer isn't just a random wrong answer. A good multiple choice question, the wrong answers should kind of have a reason behind them. For instance, do you notice what I did in this answer?
It's in respect to y rather than
Yeah.
x.
In case for some reason you've not quite grasped the partial derivative thing, and you think when you do a partial derivative with x, that means x is a constant and y is a variable, right? And you interpret it wrongly, and that's what you would have written, right? Yeah. In this one here, I'm just assuming that you didn't pay attention and you thought there were x's, and that's all you needed to think about, and you made them go away. In this one, actually, I'm thinking you're doing a product rule, and then I would have done another product rule, and you'd get a really big, ugly thing. And the reason why you might do that is that if you look at this and you don't treat that as a constant, won't you treat that as a product draw? And that is wrong. Partial differentiation, that's not what you do with y, right? Y is considered a constant. So when you're doing a multiple choice question, if I've done a good multiple choice question, I will try and find some of the most common mistakes that people make, do that mistake, and write down the answer you would get doing that mistake, which is not very nice for you, because couldn't you get the same answer as me, but it's just the same wrong answer as me? And very often you get an answer and you say, oh, it's C, I must have done it right. Well, hopefully that's correct. It was C and you did do it right. But couldn't it be, I made a mistake and he predicted that mistake and now I've chosen the wrong answer because of that? If you do a multiple choice question and it's none of the 4 choices, what's the problem? Because there's 2 possible problems.
Either I made a mistake or you made a mistake.
We nailed it. One of us 2 has done something wrong. So here's the good news. If I do that and it's after the final exam that I suddenly figure it out, because I'm seeing answers all over the place, you just get the points for it. Everybody gets it right. So you can't lose it. And remember my 5-minute rule? If it ain't working in 5 minutes, it's C. And if it was me that screwed up, you're going to get it correct. Right? Because I screwed up. Now, if you screwed up, it is worthwhile doing it a second time, right? Just in case. And I try my best, but you know my success rate is weak, to not make that happen. I really do. But it will happen. No, it might happen. Let's not be certain about things. I might get them all correct. I might do them all perfectly. Okay, next question. Off topic, or
Oh, I have another one on the same section.
okay,
It's
what's the
number
question?
12.
And what's it asking? Is it a long one again, or?
No, it's not.
Oh,
It
wait a minute,
says
I've got that open, so I've got it.
Oh, okay, great.
My version of it is e to the 8z is equal to x, y, z, and the key here is implicit differentiation. So it says use implicit differentiation, and you're being asked to find, well, one of the things you've been asked to find is that guy. Now, when it's implicit differentiation, what we have to understand here is that we are now going to think of z as a function of x and y. Just like Calc 1, remember in Calc 1 implicit differentiation, if you wanted to differentiate that, didn't you do a product rule because this was considered a function of x? So how's that going to affect our answer? Well, we'll start with this fella. If you differentiate e to the 8z, you do get e to the 8z, right? Times the derivative of 8z, which is 8 dz by dx. Now, what about x, y, z? Well, I'm going to call that f, and I'm going to call this guy g, so that's going to be a product rule.
Wait, why is it 8 dz dx?
Well, what do you get if you differentiate 8z? You get 8, right? But if z is a function of x, you get 8 dz by dx. Analogy, if I asked you to find e to the y in Calc 1, well, let me make it 8y. If I asked you to find this derivative using implicit differentiation in Calc 1, you would say e to the 8y times 8 dy by dx. Can you remember doing implicit in Calc 1? That's the same thing that's happening here. So oh God, one was implicit. What would you do? 2 days at most in Calc 1? 1 day maybe? 2 days probably. Now, Differentiate xy, partial derivative with respect to x, gets you y. Leave the second guy alone. Leave the first guy alone and differentiate this guy with respect to x, and you get that. So we are looking at that fella. And by the way, this question would have to be a section 2 question. It's got too much in it to be a multiple choice. What do I have to do here is I need to find that guy. And this is what I've got. I've done implicit differentiation to everything. And this is what I've got. What do I do next?
Subtract xy dz dx.
And the reason you want to do that, if I put words into your own mouth, is that you want to get the dz by dx's on the same side. Now, once you've done that, I don't know why I called that z, well, I'll turn it back into yz. What do you do on the left-hand side here? Remember, our goal is to get dz by dx on its own. So what do we do on the left-hand side here?
You factor out the dz by dx.
Correct. And that leaves me with that ugly guy. And then divide. And you get a very, very similar result if you do the other one. Now, dz by dx is this fella. I'd like to do this quickly. This side is not symmetric. Would you agree that x and y are symmetric? In other words, whatever happens to x, the same thing is going to happen to y. Then I should be able to predict the answer. Okay, anybody want to have a shot at predicting what this would be just by using symmetry?
Replace y with x.
Okay. And I know you should call that yx, but can we just call it xy because it looks pretty? Now, do you see that's, okay, it hasn't saved you a fortune, but would you agree it saves you a couple of minutes and less chances of, screwing up because less chances to do it? Please just remember to write by symmetry so that I know that you're not just guessing. Are we good? Let me pick a question, still on partial derivatives. If I gave you this question to do, isn't this a third degree partial derivative? Now, in the order that I've written it, you would do x first, y second, y third, right? This would be a multiple choice question. I would not do this question in that order. Because trying to differentiate this ugly mess with respect to x you would lose a month of your life because it probably would have so many levels inside other levels with chain rules, inside more chain rules and quotient rules and God, you name it, and it's in there. What order would I calculate that partial derivative?
YYX.
Now, y makes that disappear. Y again makes that disappear. So don't I only do that guy and then that guy? Do you see how quick my answer is?
Wait, wouldn't it be 0?
Not for the y's. Oh, with x. Oh, sorry. Yes, it would be. You're right. Forgot about the last derivative. That would be zy, and this would, well, actually it wouldn't be. It'd be an ugly term that I'm not going to write, essentially, that ugly term. And then when you did it the second time, that ugly term disappears, and you get that. And then when you do the x's, you get that. If you were looking at this question and you were saying to yourself, oh God, I'm going to have to differentiate this with respect to x, that's going to take me forever. But it's a multiple choice question. Shouldn't that be a signal that that's not the way to do it? And so go looking for other ways to do it. Okay, next question. Good grief, time's shot by. We've got time for one more question, or topic, or what? Question about anything really.
Can we do a comparison test question?
Limit comparison test?
Yeah.
Okay. Okay, so let's suppose I was being asked to do a limit comparison test on that series, right? Does it converge? Does it diverge? First thing you need to do is you need to, what I call surgery, you need to find out who the comparison function is, who you're going to compare them to. So you only use the biggest power on the top and the biggest power on the bottom. And that oh, darn it in space. Can I make that cubed to make it more interesting? There. So what does that get me? It gets me 2/3 there, right? There we go. Now, the 2/3 doesn't really matter because doesn't that behave like 1/n? Because 2/3, 1/n is the same thing, right? So I might use that as my comparison. And AN is the untouched version. So I would use as my comparison the simplest looking function I can get. Does anybody just know what that series does? Does it converge or diverge? Because my answer is going to do the same thing. What does this do?
Does it converge to 2/3?
What, this thing here? Oh, this limit converges to 2/3, but what does this series do? Does this series converge or does this series diverge?
Diverges.
It's a harmonic series, right? It diverges. So I already know what the answer is going to be. The rest is proof. And the proof we're going to use is called the limit comparison test. And what the limit comparison test says is that you find the limit of that ratio. And if it's a number, and it has to be a number, and the number is not allowed to be 0 or infinity, right? So as well, actually 0 is okay, but don't be infinity, right? Then you are good to go. And if you've chosen a good version of this, it will always be a number. right? So if you come up and you do this and you find out that the answer's weird, it's probably because you didn't choose a good comparison function. So let's see what that looks like. Its limit is n tends to infinity of this ugly fella all divided by this guy. And this becomes the limit as n tends to infinity of 2n squared plus n plus 7 over 3n cubed plus 1. Isn't dividing by 1 over n the same as multiplying by n over 1? And that typically in these questions, you end up with a polynomial situation. So I've got this guy over this guy. What's that limit going to be? I could probably tell, hopefully you can as well, just by looking at it. What's the limit of this going to be?
2/3.
2/3. Now you can choose how you're going to prove that. I'm just running out of time, but you have to prove it. So couldn't you prove it by dividing top and bottom by n cubed and brute forcing it? Couldn't you do L'Hopital a couple of times and get the same answer? Now, once you get to here, the limit comparison test is pretty much saying that your series, that's this one, behaves like this series. And since this diverges, so does yours. Now, if you were doing the homework in WebAssign, don't you just get two circles, one converge, one diverge? And now you may have got into that lazy thing where, hey, I get 3 guesses. I'll guess the first one. If it doesn't work, I'll guess the second one. 10 seconds and I've got all the points for the homework. Well, I guess you do. You do have all the points for the homework. Aren't you now in trouble when it comes to doing the exam because you have to do all the working to come up with that conclusion? And that's going to be something you need to work on a lot to it. This would be a section 2 question. Now, if I made it a section 1 question, I wouldn't need to say any working. In which case you could get the answer by just doing the surgery, couldn't you? And in a multiple choice, that's fine, because I don't see any working. I don't need to see any shortcuts that you might take. But in section 2, it's more formal. So you must show me the working start to finish. That's part of the process, proving that what you've got is correct. And that's time to say hi and bye-bye. You know the test, we've still got you tomorrow, so you're going to have some questions maybe on the test, but it doesn't need to be if you don't want it to be. It can be whatever you want. Okay. Bye-bye. No else. Don't know what else to say.
I have a question about.
Oh, yeah.
So is test 5 going to be on Monday?
Yes.
Okay. And then the finals would be Thursday.
Yes.
Okay.
Oh, nice short questions like that.
Yeah. Well, making sure I heard it right. I didn't want to find out that the finals on
Tuesday,
Monday.
which is, well, it won't be on
Tuesday.
Monday, no. But hopefully I mentioned that, I think I did anyway, that if you've got 4 good test scores, you don't need to turn up on Monday, you'll get the attendance, because you might want to spend that time revising for the final. So if you've got 4 good tests and you don't think it's going to make much difference, then don't bother. If you think you might do a bit better and, you know, up a couple of points, then totally feel free to turn up. Test 5 is just like all the other tests. It's WebAssign, Zoom, you know, what I always do, right? The final's different. The final's going to be a PDF that you see. And you write it down in paper and you do, the work, and then you show me it.
Yeah.
Any other questions? Kathy, you just hanging about to tell me which ones I need to check? Or you got a question? Okay. I'm ready if you got some list. Oh, you'll have to hit the space bar. Can't hear you. Still can't hear you.
And there, okay.
There.
So your answer for 11 on the section 2.
Section 2, number
It
11.
says 3.2
Mhm.
n to the, or 3.2 to the n, x to the n. Shouldn't it be 3 times 2 to the n, x to the n?
Oh God, that could easily happen because that looks very similar when you see it. Let me double check what you said there. And I'll open this guy up and we'll have a look at it. Come on, computer. It's very slow today. Or maybe I'm just impatient. Right, I'm going to put it up. It's loading up. That's good. I'll put it on full. We'll switch it over. We can all have a look at it. So section 2, question 11. So I'll make it bigger. It's about here. Oh, pretty close. Right, this fella here.
Yeah, it says 3.2. It should be 3 times 2 to the n, x to the n.
Oh, so really I just need to stick a little bracket in there.
Yeah.
Yeah, I think I meant 3 times 2, but my decimal point should be up a bit, shouldn't it?
Yes.
Yes, but that is something I will fix.
And then if you scroll down for the answer on 12,
yes,
I'm not sure how you got that -5, because our x is less than, or excuse me, the interval
it
of
isn't
convergence
even the
is
same
-3.
numbers.
Yeah,
Yeah,
-130.
that's just a typo.
Yeah.
So that should be what -1/3 and 1/3 based on what's happening above.
Yes, the brackets are good the way you have them, but the numbers just took completely off.
Agreed. Okay.
And I think that was it. Maybe. Oh, I think I sent you another email late last night. So there's one other, but I don't remember what it is without looking at the email.
I'll look at the email and I'll fix it. So by the time you see this later today, the 3 will have a bracket around it or something. It's kind of difficult to do 3 times something because it looks like 3.2 or it looks like 32. Neither of our.
Yeah, without putting, needing to put
so
brackets.
I'll put a bracket around it. I think it's the easiest way to make that happen. And the other one's just weird. Don't know.
Oh, there was also number 10. If you scroll up, if you look at the last series that you have at the top of the page, you see that you've got 2 series that are identical.
Ooh, and this guy.
It has been left off, yes.
Should be that guy. Gotcha.
Yeah.
Thank you.
That's all I've come up with so far, though.
That's enough. But the good news is it gets closer to perfection every time.
Yes.
Well, maybe not perfection. It gets closer to not being wrong. But thank you again.
You're
it's
welcome.
It's very helpful when you do this for me. Right. And any other questions before we call this a day? And I'll start moving, start fixing those things and putting them up.
Could we do one more question?
Sure.
Okay, so this one is, what section is it? It's linear planes. And question 13, so we're finding the equation of a plane given 3 points. And the points are 0, 8, 8, 8, 0, 8.
Hold on a second. I'll put it on the front screen so we can all see it.
Okay.
Right, so that's the first one. I'll call that P. The next one I'm going to call it Q. What was Q?
Q is 808
Okay, a lot of 8s in these. And the last one.
is 880.
Right. Now, you want the equation of the plane. Can we just pretend that this is 3D?
Mhm.
What we're going to do is find the equation of this plane, but the strategy that I'm going to use is I'm going to find these two vectors, and that will allow me to get a vector perpendicular to them, which is called the normal to the plane. And I'm going to use this guy as my x naught, y naught, z naught. You put that together, I'll have the equation. So let's see. PQ is second takeaway first, so that's 8. Then it's -8, and then it's 0. And if you want PR, it's 8 take away 0, it's 8 take away 8, and it's 0 take away 8. You get that. Are you comfortable about the PQ and the PR?
Yes.
Right. So the cross product of PQ and PR will be the normal to this plane. So that's going to be an I, J, K then, and 8, -8, and 0, and 8, 0, and -8. Okay, let's cover this fella up. Positive 64 take away nothing is 64. Cover the middle one up. Negative 64 take away 0 is -64. And cover the end one up. 0 take away that guy is positive 64. And it ends up being 64, 64, 64. That's kind of elegant. So far, so good.
Yes.
And the equation of a plane, which has a normal ABC and passes through a point called x, it's x naught, I think it's called x naught, y naught, z naught, is given as ax plus by plus cz, ax naught, by naught, cz naught. In our case, 64x plus 64y plus 64, that's 64z is equal to, what's p again? 088. So 088. And this is all the 64s. So I got a 64, 0, a 64 times 8, and a 64 times 8. And 64 times 8, and since there's 2 of them, I get 1024. So I have 64x plus 64y plus 64z equals 1024. Now the problem with the equation of a plane, just like the equation of a line in 3D, is that they are not unique. So I am going to do some style points. And I have noticed that you can divide everybody by 64. And when I do that, and let me just check that that's 16 and not 8. 1024 divided by 64 is 16. And that is also the equation of the plane, but that's a much nicer version of the equation of the plane.
Okay. That makes sense. Okay, cool.
Okay.
That was it.
That's it. I will see you all tomorrow then, guys, unless there's another question. First thing I'm going to do is go back and tidy up that solution thing to make it a little bit cleaner. And I'll see you all tomorrow.
Bye. Have a good day.
Bye-bye.
Thank you.